Okay, good morning, good afternoon, good evening, depending on when you listen to this slide presentation. My name is Victor, and I'm going to be your anchor for this training. Okay, this is the Cisco ITN, Introduction to Networking. It's a three-part series. So the first series is Intro to Networking. The second series is Routing, Switching, and Wireless Essentials. And the last series for the CCNA track is Enterprise Networking, Security, and Automation. So you call it ENSA. Okay, this is the fourth module in the ITN course. And we've done module 1, module 2, and module 3. Then we're now in module 4. In module 1, we looked at networking today, how it impacts our life, why it's so necessary for us to understand networking for all of the devices you use, either handheld devices, your phones, your cars, gates, IoT devices, for interoperability, for us to be able to intercommunicate between different devices, different manufacturers. There is need for networking. Then in module 2, we looked at how do we configure some of these end devices. We talked about the three things that makes up a network: the end devices, the intermediary devices, and also the medium or the media. So the end devices will be all of those tablets, phones, printers, typically everything that you use to connect to your network. Then the intermediary devices are going to be those guys that help us to communicate between each other, like the switch, the routers, and the access points and the rest. Then the media is going to be how do we connect to this or through to these end devices. So are we going to be using infrared? Are we going to be using wireless? Are we going to be using Bluetooth? Are we going to be using copper cable? Are we going to be using fiber optics? Whatever means that we use to connect. Then in module 3, we looked at protocols. We looked at the TCP/IP, and we looked at the OSI model. I use this acronym. Please do not take sweet potatoes alone. Yes, I love sweet potatoes. So the very first P is the physical layer. Then D is the data link layer. N is the network layer. That's layer 3. S is the session layer. P is the presentation layer, and A is the application layer. So we'll walk through the OSI model, the different layers. And since P, which is the first layer, is physical layer, we're going to be considering that in module 4. So if you've not liked, if you've not subscribed, if you've not shared this, please make sure you do that. Okay, we're going to start the course. We're going to see how to zoom this out. Okay, so what are the objectives for this particular module? We want to explain how the physical layer protocol services and network media support communications across data networks. So this is very, very critical because, for instance, your hardware, your cable, that NIC card and whatever dwells at this physical layer. That's the very first layer, your OSI model. So we want to understand what the purpose of the physical layer, what are the characteristics. We want to understand copper cabling, UTP cable, that is the unsheeted or shielded twisted pair. Then we look at fiber optics cabling, and we also look at wireless media. What's the purpose of the physical layer? So before you can connect to any network, there must be that physical interaction, right? So where does that happen? That place where you plug in the wire, or that place where you now tap via wireless. So that's the physical layer. So before that can happen, the NIC is very important. So if your device don't have an NIC card, then you cannot connect to a network. So that's why if you go through the Cisco ITE course, that's the Cisco Information Technology Essential course, is also on the channel. You'll see that in troubleshooting hardware issues, at times, for instance, for a system that cannot connect to the network, one of the issues might be the NIC card. So in troubleshooting whatever thing that happens to your network, you want to start from the very bare minimum. You want to start from the physical layer. So that's where the NIC is. That's the place where you plug in your network cable, or if the device have wireless enabled. So the physical layer transport bits across the network media. So you could accept complete frames from the data link layer, which is layer 2, encodes it. Don't forget, we talked about data encapsulation and de-encapsulation. So that data from the physical layer is being wrapped into the data link layer and moved up the ladder up to the very last application layer. Now, what are the characteristics of the physical layer? So you see, this is the TCP/IP standard. You can still call this the OSI model. So this is the physical data link network transport section, presentation, and application. So what are the characteristics and standards? So you see the ISO, the EIA, the ITU, the ANSI, and the IEEE. So these are regulations. We looked at it in the previous module that regulates how this physical layer should be manufactured. So no matter the vendor, you must conform to ISO standards. You must conform to IEEE standards, the International Electrical something that make sure that for every electrical device that is being manufactured, people keep to standards so that we can have, like I said earlier on, interoperability. People can interoperate. Devices can interoperate. It doesn't matter the device manufacturer, they can still communicate. So physical layer standards address the three functional areas. So physical components, the encoding, and the signals. Don't forget, it's that physical layer that gives you light blinks. You see an amber color, you see a green color to let you know if there's activity, if it's transmitting data, or amber when it's maybe have issues and the rest. So the physical components are hardware devices, they're media and other connectors that transmit the signal that represent the bits. So all of this operates at the physical layer. And as a network engineer, you want to know what happens at each of the different layers in the OSI model. You want to know what happens here, what happens here. Like I told you, at the physical layer, all of this, your hardware operates there. I don't mean your switch, I don't mean your router, no. That NIC card, that light blinking, your Ethernet cable, your fiber optics, wireless, Bluetooth, whatever, all of that physical layer, because that is your access into the network. The data link layer, we're going to look at it later on. That's where you have the switch, then you have your router at layer 3, then other stuff takes up the remaining layer till you have your application layer where you have your softwares being used. Now encoding. So encoding typically is converting the stream of bits into a format recognizable by the next device or the next layer. So we know computers will normally say zeros and ones. So those zeros and ones, I think in other chapters in the course, we're going to do some math, some binary, some conversion, and the rest. So the signaling method is how the bit values, ones and zeros are represented on the physical medium. All right, because data is not being transmitted just like the way you send it, where you see it within your software at the application layer. No, it's always been transmitted in zeros and ones. So few things you need to understand is what's bandwidth. So it's the capacity at which a medium can carry data. Look at it as your bandwidth is going to be, let's say you have a 2-lane road, a 5-lane road, a 6-lane road, a 7-lane road. So if you have a small bandwidth, if you have a small allowance, that will tell what you can take. There are some units to bandwidth. So you have bits per second. This is how you abbreviate it. You have kilobits per second. You have megabits per second. You have gigabits per second. Then you have terabits per second. At times, some people say bytes. Bytes per second, kilobytes per second, megabytes per second, gigabytes per second, then terabyte per second. Then bandwidth terminology. For ISPs, for instance, you hear things like latency, right? So if somebody tells you that we have low latency, what does it mean? It means from the distance between where we receive data or info from your ISP to how you now start using it in your router, in your switches, within your devices, it's a very short time, no delay. That's what you call latency. So for ISPs, you're always looking for low latency. You don't want to have very, very long delays in transmitting data. So if you have low latency, it means you have a fast internet or communication. Then throughput. So it's the measure of the transfer of bits across the medium over a given period of time. For instance, for ISPs, at times you wonder, why do you have low latency and low throughput? For instance, if you run a subscription-based internet service by your internet service provider, they might tell you, okay, we're giving you 1 terabyte throughput, 1 terabyte data over, let's say, 30 days. The question is, can you get 1 terabyte at the end of the day? That's what brings me to good put. So good put is the measure of usable data transferred over a given period of time. So the question is, if you're giving 1 terabyte, can you utilize 1 terabyte? Or at the end of the day, you just have like 700 something gigabytes. So you might have an ISP that gives you low latency, gives you a big throughput, but gives you low good put. So imagine you buy a 1 gig data size, but you just find out that you don't even get to use it's fast, but you don't get to even use up to 300, 400, 500 MB. What happens to the remaining data I didn't utilize? That's your traffic overhead. That is your burn. That is your inefficiency in transfer of that data from your ISP down to your building or your system where you're going to be utilizing that network. So copper cabling. So there are several ways that and characteristics that copper cabling is being done. Some of the things that you need to understand when it comes to using copper cables as your normal cables, it comes in different shapes, different sizes, different characteristics. We're going to look at that. There is limitation that can result because, for instance, if it's fiber optics, it's light being transferred from point A to point B. If it is your normal Cat 5, Cat 6, Cat 7, Cat 8, I think there's even Cat up to Cat 9 or 11. Now it's going to be electrical impulse. So that's transmission of signal from point A to point B. Attenuation is when you have a longer distance to cover, your signal becomes weak. That's why when you go buy a Cat 5 or Cat 6 cable, it comes in 300 meters. Because after 300 meters, you start having attenuation. Even depending on the quality of the cable, the copper cable, even at 100 meters, you can start having attenuation. You can start having loss of signals. Then how do you mitigate that? Strict adherence to cable length limit, like I just spoke about. And of course, grounding and other stuff. So the different types of copper cables, you have the UTP unshaded twisted pair, the shaded twisted pair, the quasar cable. So this guy will lose signal compared to this guy, then compared to this guy. Why? You see this shielding, it helps. Don't forget, we say one of the limitations, it's electrical signal is susceptible to interference from other sources. So if you have interference, so what this shield does is that it shields these guys from other interference. This guy does the job very, very well, coaxial. So you have limited interference from other signals and devices and the rest. So that's why this is always very cheap compared to this, then compared to this. So characteristics of UTP, that's unshaded twisted pair. The outer jacket protects the copper wires from physical damage. The twisted pair protects the signal from interference. The color-coded plastic insulation electrically insulates the wire from each other and identifies each pair. So you normally have yellow, white, you have green, white, blue, white, and brown, white. So you terminate them by RJ45 connectors. Then for this, right? This is shielded. So this, I remember there was a time I had to run a network for about 50 systems, boy. Because this guy is hard, you see, this guy is easier because there's no cabling, there's no support, there's no shielding. So it's easier to crimp these cables, but quite harder to do crimping for these cables because of all of this stuff. So if you cut this part open, you have to allow this guy to give way, hold them. They're much stronger. So they have better noise protection than unshielded twisted pair. They're more expensive, like I said. They are harder to install because they are very, very hard. At the end of 4 or 5 hours, my hands were very, very sore because you have to hold them at this point and do your crimping. So the other guys are a little bit easier to crimp because they're very, very light. And that's why they are cheaper. Then, of course, you have coaxial cable, same thing, more protection and gives you more protection against interference. So you see most cable, or depending on the kind of connection you're doing, you might use it. This is still copper cable. So UTP cabling, so you need to understand that there are 4, so I say 4 twisted pair. So you have the brown, white, green, white, blue, white, orange, white. So if you see the way the color is, it's this is the pure brown. So it's all brown. Then you have the one that have brown with a white stripe. So I normally say brown, white, green, white, blue, white, and orange, white. So UTP has 4 pair of color-coded copper wires twisted together and encased in a flexible plastic sheet. No shielding is used, right? So this is unshielded. So nothing is shielded. Okay. The next guy. So this guy have, so this is still UTP. So this is Cat 3, Cat 5, and Cat 5 extended. This is Cat 6. So you see Cat 6 is shielded, right? It's a little bit, like we said, more harder to implement, but still same twisted pair, right? It then means that you still have 4 pairs. That is blue, white, orange, white, green, white, and brown, white. So cabling standards and connectors. So this is what you call your RJ45. Then there is this RJ11 for telephone, right? So, but this is called 45. The telephone is the one that's smaller. So this is what the jacket looks like. So this is poorly terminated. So you want to have this properly terminated and make sure that this is entering into this. I will release a video on how to do this crimping. So if you crimp your cables this way, what happens is that these guys will easily get off the hook. What happens is that there's small metals on this guy, about 8 of them. So once you crimp, what happens is that each gets in contact with a metal within the cables, and that's why you have connection. So if you do this way, it can easily get weak and pull out. So this is the pairs. So you have, so there are different standards. So I prefer this standard, the T568B. So these are the cable types, the standard, and the application. But somehow over the years, back in the days, let's say like 12, 13, 14, 15 years ago, this used to be a concern when you talk about host to network device or host to host, switch to switch, router to router. But I can tell you for sure, we can also debate that or do more research on that. most recent devices and gadgets don't want to care whether you're using cross or whether you're using crossover or whether you're using straight through. They will get themselves sorted out, right? So, but the standard normally is if you are doing straight through, that's that you're connecting from a host to a network device, right? So that's from like a PC to a maybe another device. You could use straight through. So crossover, when you are running your cable, same type of device. So host to host, switch to switch, router to router. So this is like PC to switch or switch to PC. So both ends at this or this. So you could so you call it straight through. So you are starting with this, and the other end you're running it this way. So it then means that when you pick up your cable, there's this cable, right? Once you pick up this cable, how do you arrange it? You arrange it this standard, right? You must make sure at this far left, you sort green, green, white, and green, orange, orange, white, and blue, blue, white, blue, blue, white, and orange. So because when you just get your cable is going to be in their pairs. So you have to rearrange them. You have to rearrange them into this format before you now crimp. If you don't do it properly, then it's not going to work. Remember one time I was in an installation, we had to do the job with a guy, and the guy was not getting the standard. So I had to draw this out for him to get the standard, because if you don't get the standard properly, you have to cut it off and redo it. So the standard has to be done, right? If you don't follow the standard, your cable is not going to work. So we're saying if it's host to host, you could start like this, and the other end, it's like this. But if it's host to host or switch to switch or router to router or PC to PC, you start this way and end the other way, right? Okay. So considered legacy due to most NICs using AutoMDIX to sense cable types and complete connection. So like I told you, most of these new guys now, they want to care whatever, but make sure that you follow at least one of the standard in whether you're doing crossover or straight through. So you say straight through when it's different device type. You say crossover when it's same device type. So you just get a check there. So for fiber optics, so it's not as common because it's expensive. Of course, but it's much faster. So you have minimum signal loss. You could transmit over a longer distance. It's less susceptible to attenuation, that is loss of interference through electromagnetic interference. So it's made of flexible, extremely thin strand of very pure glass. So that's why it's very expensive. This is what it looks like. So you have the glass core, then you have the glass cladding, then you have the polymetric coating, right? So this is where the signal moves within the glass core. So fiber optics cable is now being used in 4 types of industry: enterprise, fiber to home, long overhaul network, submarine. So you have from one continent to the other continent, your only best bet is going to be fiber optics. So fiber optic connector, so you this is a straight tip subscriber connector. So this is what goes into the subscriber stuff. Then this is your Lucent connectors, and this is your duplex multi-mode LC connectors. So you see the connectors are a little bit different from the what's it called? The one for copper cables. So a yellow jacket is for single mode fiber cables, and orange or aqua for multi-mode fiber cables. So depending on your installation type. So fiber versus copper. So you can't just compare those guys. They're just way different in terms of the speed they can support, the bandwidth, the distance they can cover. This guy can go. Okay, let me do a little check. End slideshow. So let me say Nigeria to Canada, or let me say UK. So distance, kilometer. So Nigeria distance to country. I'm in Nigeria currently. I'm in FCT, Abuja, the city center, the federal capital of Nigeria. So this is UK. Nigeria to UK is 5256 kilometer. You see, this guy can go way, way, way far. That is just 5,000 kilometers. Fiber optics can go, okay, sorry. This is 100,000 meters. So 100, this should be 100 kilometers, right? Am I right? Yes, correct. So if I compare it to this is 5,000. So I could have bridges in between, right? This is meters, so this should be 100 kilometers. Yes, I think I'm right. So of course you can, but this is just 100 meters. EMI, very low, very, very immune, fiber optics. So for very high-end connection enterprise deployment, you want to go for fiber optics, especially when you are moving distances away from buildings. That's when you go for fiber optics. But if it's within your building, of course, you want to use copper cables. Okay, wireless media. So properties of wireless media. So, we're looking at our physical layer. How do we make our connections? Are we using copper cables? Are we using fiber optics? Are we using wireless? So some of the limitations of wireless is the coverage area, interference, security, and of course, is a shared medium. So you have some standards here, the Wi-Fi, the Bluetooth, the WiMAX, and the Zigbee. So in general, wireless LAN requires the following device. So if you have a wireless connection, you must have a wireless network interface card to go to pick your signal. If your laptop, if your phone does not have wireless enabled, then you cannot do that. Or if you don't have wireless access point to help you extend your wireless signal, then it will be difficult for you to catch up signals. There's something here about security. Network administrator must develop and apply stringent security policies and processes to prevent wireless LAN from unauthorized access and damage. Yes. If you go through the Cisco Cyber Ops course, one of the things you want to be interested in doing as a cybersecurity enthusiast, engineer, analyst is that you want to have a network security policy for your organization. How do you do that? You first do an audit for your organization, understand what you have in your organization. Then you look at standard guidelines. Then you adapt what you have in standard guidelines. There are several frameworks like the NIST, and of course, several organizations that already have their network security information policy or security policy. Adapt that to yours. Make sure that HR, C-level executives, the IT team within the organization provides input to your information security policy document. Then you make sure there are penalties when people go astray. Then you train everyone on the policy document. Then people sign it, and it now becomes a policy document. So that's what the process looks like. I just tried to give you a heads up. So there's a packet tracer lab. We're going to do that later on. So how do you connect to the cloud? How do you connect to the router? How How do you connect some devices? How do you verify connections? How do you examine the physical topology that you have? There's another lab, how to work with PCNIC and how to use the system tree network icons. Okay, that's all for module 4. Thank you for staying through up to this moment. My name remains Victor, and we're going to be looking at module 5 next. We learned about network communications, the physical layer, the different types of cabling, and that's UTP, STP. So this UTP is unshaded twisted pair, STP is shaded twisted pair. So this is cheaper, even easier to crimp and run because it's lighter. This is more expensive and because it's shielded. So of course, more cost of production. Then you could run straight through or crossover cables. So say straight through for different devices, like my PC to my switch or router. Then crossover for same type of device, PC to PC and router to router or switch to switch. But like we said, most recent devices now are not going to bother about that. They will like auto detect whatever cabling that you do. Okay, I think that's all. Thank you very much. See you. Okay, there's a packet tracer here. Like I said, all of the packet tracer, we're going to do them at the end of the course. Thank you very much. See you in the next module.